Well, hey everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's video. Today's video, we're going to talk about bonding in Part 5 of Article 250. In today's episode, we're going to specifically stick to service bonding, and that is on the supply side or line side of a service disconnection means. However, we will talk about the general rule that applies to the entire part of 250 dealing with Part 5, which is bonding. Now, why do we do bonding? Now, bonding shall be provided where necessary to ensure electrical continuity and the capacity to conduct safely any fault current likely to be imposed. Now, if we're talking about supply side bonding, that means that any raceway, any enclosure, any wireway that contains service conductors or that are imposed in the service system coming up to the supply side of a service disconnect, all that metal needs to be tied together. It needs to be bonded together. Okay, so it's at the same potential, but it also allows an effective fault current path to get back to the source. In this case, the source is back at the transformer, where you might have an overcurrent device up there that might assist in clearing this if you have a supply side fault condition. Now, when it comes to the load side, that means from the service disconnect down to feeders or branch circuits out to the loads, then you want to make sure that whatever wiring method you use, that it is actually, for example, if it's EMT, which is listed as an equipment grounded conductor under 250.118, that it can safely and effectively carry the fault current. It means you use the proper fittings, the proper couplings, you make the connections properly in order for it to safely carry any potential fault current back to its source of its overcurrent device so that the current can get back to the source, which ultimately is a transformer. But by allowing that fault's energy to skyrocket, it allows that breaker the time, or fuse the time, to react properly and shut that system down. So if you don't have this low impedance fault current path back to the source, then you're not going to allow that fault current to build up at the place of the fault, and you won't allow that overcurrent device to operate properly. So we need to make sure that if you're running non-metallic sheath cable, that you have all of your equipment grounded conductors terminated properly, spliced together properly in junction boxes, everything done properly, so that in the event of fault current, that current can get back to the source, allowing the current to skyrocket at that location of the fault just enough so that that overcurrent protective device can activate properly. Okay, and so that's why we're doing all this bonding on the load side of a service disconnect in order to clear a breaker. On the line side, we're bonding everything together in order to create the same potential and to do the same thing in a chance that we have any overcurrent protection on the supply side of our service disconnect. Okay, and that is controlled by the utility. We don't control that, but you're giving it the best opportunity to do that. And then sometimes you might have service conductors that can get current imposed on it, and it allows it to get down to the earth through your grounding electroconductor where necessary, and then go through and get back to the actual transformer. Because when you're dealing with higher levels of current or higher levels of voltage, then it's much easier to clear an overcurrent device of a smaller type than what we have to deal with on the secondary side of a transformer inside of a premise, where we're going to take a little bit more current in order to clear any type of overcurrent device that might be in a panel inside of a building. Okay, so we want to make sure that we separate the two. So we've got the supply side bonding, and we got what we call the load side bonding. And so today's episode, we're going to talk about the supply side portion of this. And remember now, on the load side, you've got equipment grounded conductors. You got different types of wiring methods that might qualify as an equipment grounded conductor. By going to 250.118, you can see a list of them there, like EMT, rigid, IMC, AAC cable, certain types of specific lengths and size restrictions, for example, on FMC. You have all these rules for what can be considered an equipment grounded conductor, which is vital because that allows the fault current to get back to the panel, ultimately back to the source, but it allows that breaker to function properly. Okay, that's dealing with the load side. We're going to deal with the supply side, and we're going to deal with the services in today's episode. So as you see here, we're going to deal with 250.92. We're dealing with services. Now, we're going to have an A and a B. Now, A is going to tell us what all we have to bond together, and B is going to give us the methods for achieving that. So under A, it says the normally non-current carrying metal parts of equipment indicated in 250.92A1 and A2 shall be bonded together. A little code tip here. Anytime you see the word and, that means this and that both have to be met. If you see an or in here, then it would be this or that requirement would have to be met. Okay, so it allows you to meet either one. But in this case, you got to meet both of those if it's applicable. All right, so let's talk about it. Right here, number 1. Okay, it says all raceways, cable trays, cable bus framework, auxiliary gutters, or service cable armor or sheathing that enclose, contain, or support service conductors. All of those have to be bonded together. It also says, well, except for those that are permitted in 250.80. Now, what is that talking about? Well, that's up here where it tells you have to bond all metal enclosures and raceways together, and you have to bond them to the grounded system conductor. That would be the grounded neutral that typically would come down from your transformer down to your service. If you have one, if it's a grounded system, you will. That comes into the enclosure, and that goes to your neutral terminal bus. And then, of course, your premise wiring will go and connect to that same neutral bus, and typically that's where your grounding electrode conductor will go from to your grounding electrode system, and all that gets done in that service enclosure. But this is just telling you bond it all together. But down here is the one we're dealing with, this exception. Now this is saying right here that you have to bond all the raceways. Well, what if I have a non-metallic raceway underground and I want to use metal elbows? Now, why would I use metal elbows? Well, the reason I'd use metal elbows is maybe I have an underground run where there's rather large conductors, and as they get pulled through, the friction could cause it to rub and wear the inside portion of the elbow. And if you do that, you could damage, due to the heat, you could damage the conductors that you're pulling. You get sidewall damage pressure and things like that, depending on your pull. But the worst than that is you breach the integrity of that elbow. Now, many people will impose metal elbows into their underground non-metallic raceway system. And by doing that, you have an elbow that allows the conductors to slide around it a little easier. It helps with the friction, lowers the friction. Usually if you have pulling lubricants on your products, it does help it better at the pull with those elbows that are metal. And again, as long as those elbows, because you remember what it said over here? It says all raceways have to be bonded. Well, since this is non-metallic, you wouldn't bond it. But since you're imposing a elbow or some other fitting into the system, then typically by this rule here, where you have to bond it all together, that you would have to bond it. It would be isolated. But this rule right here is allowing you to not have to bond it as long as it's down in the ground below 18 inches of cover. The chances of anybody coming in contact with it are slim to none, so you don't have to bond it. So when it makes a reference right here, it's also saying except as permitted in 250.80, and that is basically saying if you have an elbow on that raceway that's down 18 inches of cover, don't worry about it. Chances of somebody coming in contact with it are slim to none. Okay? Now, the parts that come above ground, different story. Okay? Now, that's one. And now A2 is this. It reminds us that all enclosures containing service conductors, okay, that's all enclosures. Now, that would be any enclosure that's on the line side of the service disconnection means, and including the service disconnection means or the service enclosure, cabinet or what have you. All of those metal parts, all that have service conductors within them, have to be all bonded together and tied to all these other components where applicable. But it also goes on to remind you that what about the meter fittings or meter boxes and the like? Usually they're imposed into the service raceway or armor. In other words, you're coming from a weatherhead, it comes down, you have the raceway coming down, and all of a sudden you impose a metal meter socket in there, a meter enclosure. Now, typically you go to Article 312 for meter enclosures, but what it's telling you right here is, you know what, that's metal, and you're going to bond it. Now, in most cases, the grounded neutral conductor in accordance with 250.142 is going to allow you to do that. And most meters already have that incorporated into the meter socket itself. If it's typically provided by the utility, that grounded conductor will make that connection to that actual enclosure. And then you're all done because 250.142 allows you to do that. That allows you to supply side equipment bond with the grounded conductor. If you don't believe me, pause the video, go look at 250.142A, and you'll see what it's talking about. Okay? Now, in that application, then that meter enclosure is going to all be bonded and you're good to go. Again, remember that I can actually use the grounded conductor for a lot of a bonding aspect when it comes to the supply side of the service disconnection means, okay? So, as long as I'm on the supply side, I'm good to go, and I can bond all types of metal parts there. Okay, again, go to 250.142A and learn that because that can be vital to you understanding how to be some really costly savings, okay? Well, should I say costly savings as an oxymoron? A more economical savings to utilize a grounded conductor, okay? All right, so anyway, so there you go. So there's all your rules there. Now, that tells us what we have to bond. So B is going to tell us the method for doing that, okay? Now, the first thing first, if you encounter, and let me show you what I'm talking about, right here. If you encounter concentric or eccentric knockouts, those are the ones where you can remove them in succession, or you have reducing washers, all of those, then those are considered impaired knockouts. Okay, and if you have impaired knockouts, then you're going to have a bonding jumper. Okay, so that's what the code is telling us right here. It says bonding jumpers meeting the requirements of this article shall be used around impaired connections such as reducing washers or oversized concentric or eccentric knockouts. Okay, that's the first rule that you have to remember when you're dealing with those impaired connections. So in that vein, we're going to highlight that right there, and we're going to highlight it. There you go. Now, the next part that we need to know is that standard lock nuts, and we highlighted that, so now we'll just get rid of it. Standard lock nuts or bushings shall not be the only means for bonding required by this section, but shall be permitted to be installed to make mechanical connections of the raceway. Now, this means, right here, we'll highlight it. This means that when we're dealing with service size, it doesn't matter whether it's a punched hole or whether or not it's an impaired hole that you need a bonding jumper, you can't use standard lock nuts. You can't just use standard bushings for this, okay? You need to do something more, something a little more. Now, can I use the standard lock nuts for mechanical? Absolutely. Maybe that's holding the raceway, maybe it's rigid or IMC, intermediate conduit, to the enclosure, but I can't rely on standard lock nuts. I got to do something more, and that's what this is saying. All right, so then what more can we use? All right, well, then that takes us down here, and it says, okay, and we'll get rid of this here just so it doesn't clutter the screen. Now it says, electrical continuity at service equipment, service raceways, and service conductor enclosures shall be ensured by one of the following means. Okay. Now we've got 4 different items, and they don't all apply specifically to the service equipment. Some of them are specifically raceway to connector based. Some are connector or raceway to enclosure based. But you got all these different options in order to be able to make that connection. Okay. So the first one we'll look at is number 1. Okay. And you can ensure by one of the following. Okay. Any one of them. You can use more than one. Doesn't just be one. You can use multiple options for different types of raceways coming in. You're not just stuck with one of these options. Okay. Now, first one, it says bonding equipment to the grounded service conductor in a manner provided in 250.8. Okay. So what are we talking about here? All right. So remember what I said about 250.142? This is very similar. Whereas I'm actually taking the equipment and I'm literally going to bond it to the grounded service conductor. Maybe it's to the grounded service conductor bus bar. Maybe in a wireway where I'm coming in from a CT into a wireway, and then I come up from the wireways into, say, 3 specific individual panels with main breakers. Again, all those conductors on the line side or the supply side of those 3 panels are service conductors, and all of those metal enclosures and metal wireways all have to be bonded. Well, one method to do that, also that's specified in 250.142, is to bond those equipment to the grounded service conductor. So this is an allowance here that lets me do specifically what they're permitting me to do in 250.142A. But I have to do it based on one of the methods in 250.8. Now 250.8 is a list. And if you go look at 250.8, what you're going to see is you're going to have a list of different methods to be able to achieve that. And so it'll go down the list, and I'll do it. That way you don't have to go away from it. It says that I can use listed pressure connectors. I can use the terminal bars, which we tend to do that. So you actually could jump from, let's say, one of the raceways with a jumper over to the grounded service conductor. Or I could have a bus bar, terminal bar, mounted to a metal wireway that actually has the grounded service conductors laying through that terminal bar. Maybe they're lay-in lugs, and you're physically making connection between the grounded service conductor and the metal enclosure using one of the methods here in 250.8. Okay, so there's different ways to do that, and 250.8 gives you a list of methods to be able to achieve this. But probably what's used the most is probably a terminal bar or listed pressure connectors that intimately connect the grounded service conductor to the metal enclosure. And as long as you use one of the methods or the manners that are in 250.8, you're good to go. And again, like I said, that also kind of mirrors what we're doing in 250.142a. Okay, so that's kind of your first one. All right, we'll get rid of that just so it doesn't confuse us. The next one is item 2. It says connections utilizing threaded couplings or threaded hubs of enclosures if made up wrench tight. Okay, so this one, let's highlight that one. So what are we talking about here? Connection utilize threaded couplings. So I could have a threaded coupling that literally connects to the enclosure, maybe like a Myers hub or something like that. Or I could have a threaded hub that's on top of an enclosure, and I'm going to make it up wrench tight. Now, usually that is designed so that it actually connects to the very top of the enclosure, and so you have more than enough of the actual thread connection into the enclosure. Obviously, it's going to be in compliance with 250.8a anyway, so that is one of your allowances. So if that's what you have, now typically an example of this might be if I'm coming in overhead, I got service drop conductors coming to the point of attachment to the side of the building. The conductors then change over to service entrance conductors. They go up into the weatherhead. They come down, let's say a metal, let's use a rigid metal conduit coming down, and it goes to the meter, and the meter is connected to the grounded conductor, so that's taken care of. All right. That would be in accordance with B1 here, as well as in 250.142. So that's taking place. Okay, but then it comes down, let's say, into an exterior panel. And when it comes into the panel, it's coming into the top through a hub. And it threads into the hub. That hub is then connected and listed for use with that enclosure. And I'm making up that threaded conduit into that hub, and it is wrench tight. Okay, so I'm using a wrench to literally tighten it down. Then you're done. You've made that connection. And that's what we're talking about there. All right. So then that's just one example of that. Now, the next one. Next one is a little different. It tends to confuse people because they think they can use threadless couplings or connectors to the enclosure. What this is saying here is that you can use threadless couplings and connectors if made up tight for metal raceways and metal cables. So what this one is stating is that where I go from a raceway to a coupling, or I go from a raceway to a connector of the metal raceway, or from a metal cable to a metal clad cable connector that contains service conductors, then they are considered bonded. But when it makes a connection to the actual enclosure, you still have to follow all the other rules, okay? So this one is talking about the makeup of the raceways or cables to a coupling or a connector is considered, as long as, again, those raceway couplings or connectors or cable couplings or connectors are listed for that connection together, then they are considered bonded together, okay? That's what that's talking about. But when it comes to connecting those raceways or those cables to the enclosure, then like it says, ensured by one of the following methods, then you're going to have to pick up and make sure you do that by one of the others. And why do we say that? It's because I could have an application here where I have a concentric or eccentric, and I have a raceway, and I have a coupling, and those two are connected together, and they're going to meet 3. That's not a problem. But now it connects to the enclosure, and because I have a concentric or eccentric knockout, then I'm still going to have to meet the requirements for the bonding jumper application here around that impaired knockout. So we don't want to make sure that you get the impression that these all work together, but this one right here is specifically dealing with the raceway connected to the connector or the fitting, if you will, or the coupling. That is considered bonded, okay? Now, let's talk about this in a little more detail. What if I have that same issue overhead, and I've got the weatherhead and it comes in and it comes down, and maybe it's high enough up that I have a coupling between two sticks of rigid metal conduit. That coupling is a threaded coupling, and it is considered okay to bond each separate piece of raceway. Now I think it's clear what you know I'm talking about. That's what it's talking about. That coupling is okay to make that bonding connection between two different raceways. Okay, now when you get down to the enclosure, you still are going to have, now you have a separate component, right? And it's easy for people to think about this. Treat each component separate when we're talking about the service. I've got the raceway, I've got the couplings and the connectors, and now I've got the enclosure. Each one of those have to be distinctively different in how they're bonded. Okay, the raceway to raceway gets done through the threaded coupling. Okay, and a metal clad cable, for example, gets made up through a listed fitting or connector. Now you have to make that connection now to the enclosure. Now you skip over to how do you make that connection to the enclosure? Well, now you have to deal with whether or not you're dealing with a concentric or eccentric knockout, and you remember that you cannot use standard lock nuts to make this connection, so you have to do something else. So that's what makes it easy for you to separate all these things to better understand how you're applying this rule. Okay? All right, so let's get rid of this one. And let's move on to the last one, item number 4. Now, in item number 4, it says other listed devices. Again, there might be some out there that are listed for grounding and bonding, okay, and that are perfectly okay. And I will note that in 250.8a at the bottom of the permitted methods, there is a number 8 that says other listed means. Okay, so you might have some other listed means that we just don't list in the list in 250.8a. I mean, so if a manufacturer gets something evaluated for grounding and bonding, and it can handle this application, then if it's listed for that, then you can utilize it. But there are other listed devices that are listed and are available to make this service bond. What are they? Well, bonding type lock nuts, and those can be utilized. Let's say if you don't have concentric or eccentrics, you just have a perfectly cut hole, maybe a punched hole. Or maybe you removed all the knockouts out because you're using the largest one. Let's say it's trade size 4 and you've got a trade size 4 raceway coming in. Then I could use a bonding type lock nut because I got no additional concentric or eccentrics. So I no longer have an impaired connection. But I just have to do something more. I can't use a standard lock nut. Then I can use a bonding type lock nut. Okay, and a bonding type lock nut literally has a screw that drives down and connects into the actual armor and connects and cuts into the actual enclosure. Okay, then next I can use a bonding bushing. Okay, or I can use a bushing that is maybe not necessarily designed for bonding, but it has the ability to attach a bonding jumper on it, so I can utilize that as well. So then let's kind of go down here. So this right here is a bonding bushing, and it allows for the application here. This drives in, connects to the threads, and then you have this lug here, and this is a bonding jumper because we are dealing with eccentric knockouts, plus they're using a reducing washer here, so that's the application there. And again, you see in this graphic here, all of this stuff, these are your service disconnects. All of this on the line side is all getting bonded. So here you see this enclosure here getting bonded to the grounded neutral conductor. This enclosure here is also getting connected to this enclosure, which is connected to the neutral, which is perfectly allowed to take place. Here you see this raceway coming in, and we'll assume here we've got impaired knockouts. So here they've got a bonding jumper as well. And since this whole enclosure is connected to the grounded neutral conductor, then you have literally bonded this aspect of it. Now, this piece right here, these are isolated pieces, okay? And so you can bond it on this side or this side. Again, we're still on the supply side of the service disconnect. So here you see right here, this is a bonding jumper, okay? And this is a supply side bonding jumper, which is what all these are. And you would size this based on 250.102C1. And this one you size based on the conductors that are supplying it here. That's how you size this one. Same in this one. And they will tell you based on these conductor sizes, and that's how you do it. Okay? So these are your service disconnect. So all of this are service conductors involved in it. Okay, this one right here, this bonding jumper right here, this supply side bonding jumper, gets sized based on the size of these conductors here that are supplying this enclosure. Okay, in this case, you have some parallels going on. So you just take one set. Let's just use this set. Say they were 500 kc mils. That would end up being a total of 1,000 kc mils. Then you're going to go to 250-102C1, and that's how you would size that supply side bonding jumper. Pretty simple if you think about it. All right, so you go through that, and I wanted to show you as you're bonding, and that's pretty much everything on here. I didn't know if we had any additional pictures that we want to show. There you go. Here's an example of the meter. This enclosure is bonded to the neutral right here, which bonds this enclosure. Here you see the hub on top, which bonds this raceway to this hub, which bonds to this metal enclosure. Perfectly acceptable. Here's another example of a CT. We have the CT conductors coming in, and here you see the grounded neutral conductor is connected to the enclosure by this connection right here. And this is a supply side bonding jumper that is sized again based on the parallels that are coming into it, as we just discussed previously. All right. And here's some examples of that meets B1 that we talked about earlier. Here is some Myers hubs that would come in, and you see all that. And here is some bonding type bushings, again made for that. Here's a bonding wedge that you can utilize if you have no concentric or eccentric knockouts. You can slide this buddy under there and you'll be good to go. Here is that bonding type lock nut that simply, as you see here, you see this is kind of curved. It's concaved, as you see right here. These will bite into the enclosure, and this screw will bite down into the raceway. Okay, so it gets all of this takes place, and everything bites into the enclosure, and it really does make for a good connection. Okay, all right. Hopefully you got something out of that. Those are the applications. Remember, again, the takeaways: can never use a standard lock nut unless you're doing it just for mechanical purposes. If you have concentric or eccentric knockouts or some kind of impairment, then you're going to need a bonding jumper. If you're able to remove all of those knockouts and use just a pure hole, or you punch your own hole, then you might be able to get away with something like a bonding type lock nut, bonding wedge, for example, and again, you can use a bushing with the bonding jumper if you want. All of those type of aspects will allow you to make those connections. So hopefully you understand that we just have to do something a little more on the supply side of the service disconnection main. Hopefully you got something out of it. Until next time, folks, stay safe and God bless.